Hello students, in this video I will explain about gravitation. History of gravity. Ptolemy gave the theory of geocentric universe, means Earth is present at the center and all the planets revolve around the Earth. Copernicus gave the theory of heliocentric universe, means Sun is at the center and all the planets revolve around the Sun. Brahe and Kepler. Kepler used Brahe observation to formulate three laws of planetary motion. Galileo tested with gravitational effect of Earth, acceleration of gravity, first to come up with idea of inertia. Contemporary of Kepler's. Newton gave the law of universal gravitation and Einstein gave the theory of general relativity. The idea of gravity was introduced by Sir Isaac Newton. According to Newton, all body in the universe is attracted to other bodies with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between them. What made the apple fall to the ground? Every object on the surface of the earth is attracted towards the center of the earth. This force is called as gravitational force. Gravitational force directly proportional to the masses of the object and inversely proportional to square of distance between the object. Gravitation is the force of attraction between two objects in the universe. Gravitation may be attraction of the objects by the earth. For example, if a body is dropped from a certain height, it falls downward due to the earth's gravity. If a body is thrown upwards, it reaches a certain height, then falls downward due to the earth's gravity. Gravitational may be attraction between objects in outer space, attraction between earth and moon, attraction between sun and planets. Centripetal force. When a body moves in a circular path, it changes its direction at every point. The force which keeps the body in circular path act toward the center of the circle. This force is called centripetal force. If there is no centripetal force, the body will move in a straight line tangent to the circular path. Students, although the law of universal gravitation is given by the Newton, but the value of G according to Newton is very small but not determined by the Newton. The value of G, gravitational constant, is determined experimentally by Henry Cavendish. The value of G is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Dear students, now how to find out the SI unit of G? We know F is equal to G into m1 m2 upon r square. So G is equal to F r square upon m1 into m2. Write the unit of force. Force SI unit is Newton. Write the unit of distance. SI unit of distance is meter. SI unit of mass is kilogram. When we substitute this value of SI units, we get SI unit of gravitational constant G, that is Newton meter square per. G is known as universal gravitational constant because it has the same value for all the objects, that is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. The centripetal force provided to the moon is the gravitational force given by the formula F is equal to G me mo upon d square, where mo is mass of the object, ma is mass of the earth and d is the distance from the center of the earth. Students, gravitational force is independent of intervening medium and their masses. Change in temperature, pressure, or any other physical condition. This law is valid for small and large masses and distances. This law holds good for celestial bodies also. As the gravitational force between two objects is inversely proportional to the square of the distance between them, it is generally called the inverse square law. Students, using Kepler's third law of planetary motion, Newton was able to prove the inverse square law, means gravitational force between the sun and a planet is inversely proportional to the square of mean distance r between them. On the basis of data of motion of planets around the sun, Kepler derived three laws of planetary motion. These laws are: first law is known as law of orbits, states that planets orbit the sun elliptically. Second law is also known as law of area, states that line connecting a planet to the sun covers equal area over equal periods of time. Third law, also known as law of periods, allow us to establish a clear relationship between the planet's orbital period and its first, second, and third law. Kepler's third law, also known as law of period. According to this law, the square of period of revolution of the planet around the sun is directly proportional to the cube of the semi-major axis of the elliptical orbit. T square is directly proportional to r cube. According to this law, when the planet is closest to the sun, its speed is maximum, and when it's farthest from the sun, its speed is minimum. Students, why the speed is maximum near the sun? That is because of the gravitational force. Gravitational force is maximum when the planet will be near the sun, and it will be minimum when the planets will be farthest from the sun. In 1687, Newton published Mathematical Principles of Natural Philosophy, which explained the law of motion. In this book, Newton used a calculus-like method to determine the attraction of planetary body. Thank you, students.